Hello, this is Ron Gerber from Angel Beat. One of the most important subjects we cover at our Angel Beat events is cloud computing, cloud architecture. Pretty much everything is now a service, be it software, infrastructure, platform, code, etc. One of the other topics that we make sure we cover is security, and this is where cloud and security converge because the cloud computing platform creates new threat vectors that cyber criminals, hackers can exploit. But fortunately, if you've been to Angel Beat and heard from experts like Josh, the CTO and co-founder of Fugue, he'll provide you with great insights on how to go about preventing hackers from attacking your cloud applications. How do you protect yourself? So without any further ado, let me turn it over to Josh.
Well, thanks so much, and it's great to be doing this online webinar, and really enjoy the Angel Beat events live too. So yeah, as was just explained, we're going to do today a little demonstration of actual live demonstration of an attack against misconfigured cloud resources, and we're going to do that live. But first, I want to walk through just a few slides to kind of set the stage so folks understand what we're really talking about. So what we'll do this afternoon, or whenever you're watching this, is an overview of what cloud misconfiguration risk is really about. We'll do a live hacking demonstration in which I will steal data from a real cloud account. It happens to be mine. And we're not going to do much in the way of Q&A, I don't think, but we'll at least walk through those portions. So what is cloud misconfiguration? So the first thing to understand is that it is not just a major, it is the major security risk on cloud. So according to Neil McDonald at Gartner, nearly all successful attacks on cloud services are the result of customer misconfiguration, mismanagement, and mistakes. Most of these attacks take the form of stealing data or doing things like installing crypto miners in folks' accounts and so on. Fugue, we did a major survey last year of 300 organizations that are operating at scale on the cloud. And this 93% figure came from that survey. That's the number of respondents that said they were concerned for a major security breach due to misconfiguration. It really should be 100%. But I suspect the 7% that aren't worried about it might well be having their data stolen as we speak. So what cloud services can be misconfigured in a way to expose you to risk? Again, from our survey, 66% of folks said they were concerned about identity and access management misconfiguration. That was the highest number of any service types. And they're right. Again, this should be 100%, but identity and access management in cloud is very different than it was in the data center. Identity and access management in cloud is actually kind of an alternate network to the TCP/IP network that allows cloud services to talk to each other. And misconfiguration there is, as I will show in my demonstration later, particularly devastating as an attack vector if you get it wrong. And you don't have to get it very wrong. More than half said security group rule misconfiguration was a concern. Security groups on cloud are essentially firewalls. They are ingress and egress via TCP/IP to cloud resources. And then just over half said object storage access policies. So this is the infamous S3 bucket misconfiguration that folks read about in the news a lot. It's interesting that this came in third because I think those folks who aren't deeply familiar with cloud would think that would be the number one. But this, in my opinion, the survey respondents are right. What I'm going to show today is actually an S3 data breach, but I'm going to use misconfigured security groups and IAM to steal the data. Okay, cloud misconfiguration is often overlooked. So when we say cloud misconfiguration, we mean leaving settings on these cloud services, on the resources, open in a way that bad guys can exploit. Okay, and it's very dissimilar to the data center, and therefore these misconfigurations are usually overlooked because the misconfigurations are not recognized as misconfigurations by security teams. Traditional security teams are thinking more about perimeter defenses around TCP/IP networks, and that doesn't have a whole lot to do with cloud security, honestly. I mean, it is an attack vector, it remains an attack vector, but most of these cloud breaches are not going through your TCP/IP network-based perimeter defenses at all. And I'll show that later. So the misconfigurations aren't even seen as being problems, including by the big compliance frameworks that, Fugue, we support NIST 800-53, PCI, GDPR, HIPAA, CIS benchmark, et cetera. But those guys are way behind the ball on actually putting rules in, controls into those frameworks that are going to keep you safe on the cloud. They're still really in the data center in their mindset. And those two things together means that most organizations have these vulnerabilities. These are exceedingly common in enterprise cloud environments. And in a lot of ways, because cloud is constantly in motion, right? That's the beauty of cloud. It's not static. It's not like a data center that's racked and stacked. You can bring into and out of existence all kinds of resources all the time. And therefore, these misconfigurations are a lot like needles continuously appearing and disappearing in a haystack. They can be quite difficult to get your hands around. The good news is, because cloud is driven by APIs, with tools like Fugue, you can find these things and be notified of them right away. So there's no mystery to that, but you really have to know what you're looking for, which is, of course, what we kind of do for a living. So let's talk about how hackers are approaching their problem space, right? Because you have a problem space, you have a set of goals and use cases that you're trying to fulfill. You're trying to build value for your customers. You're trying to deliver value to market as quickly as you can. They are also in a business, right? And the way they approach it has changed over time. So before cloud, the most common, if you think about like the Hollywood, movie version of a hack, or if you think about the North Koreans going after Sony, the number one step is to identify the target organization. We're going to hack Sony today because they made a movie that disparaged our leader. So these things, by the way, do still happen, but they're not the dominant pattern. So step one then would be identify the target organization. Step two, search for vulnerabilities to exploit. Often these involve things like spear phishing emails, et cetera. But this is not what we're seeing for the most part these days. It does happen, but usually what we see now, including on some of the big breaches that made the news, over the last few years, is in the cloud era, the bad guys are running automation to constantly look for anything you've misconfigured. So they're running bots that identify misconfiguration vulnerabilities just 24/7. In fact, a good friend of mine who does these kinds of things for a living on the good guy side told me that the average length of time for a resource to appear on the internet, to have a public-facing IP address or DNS record, and for it to be scanned for misconfiguration is about 7 minutes. So the bad guys, instead of them targeting your organization, they're just scanning everything you put online. They're doing it within a few minutes, and then they have a shopping list of targets that they can prioritize. And we saw this again in these major breaches over the last year or two. That's usually, when you read the Department of Justice filings, when they do come out, very often that's what you'll find. So bad actors are using automation to find and exploit your cloud misconfigurations. So don't think that you have any security due to whatever relative amount of obscurity you have, if it's a public-facing address, they're finding it, and they're finding it in minutes. Okay, let's go ahead and do this simulation. So we've got the guy on the high wire here. It is a live simulation, so you know, hopefully I don't run into any. Hopefully the demo gods are with me today, and we'll see. So, oh, actually, I want to start by talking about what I'm actually going to hack. So this is a diagram. This is part of the Fugue product that we make, but it's useful to show you what I'm going to do. So over here on the left is the internet. Then there's an internet gateway, and we have an EC2 instance. This is a virtual machine. This one is appropriately titled, I've got a CVE. A CVE is a known vulnerability. Okay, so I've intentionally set up this environment to have a known scanned vulnerability, and you can see here I am in a security group, going back to the things that were big worries about misconfiguration. Security groups is number 2. This one has a vulnerable security group that I'm going to exploit. But what I really want to do, I don't really care about this compute instance. What I really want is the data, what I really want is the data over here in this customer records S3 bucket. I want to steal this data. So I'm going to try to get into this and then jump over here and steal the data and drop it in my own bucket called all your base, which is my bad guy hacker data bucket. Okay, let's get to it. So if I were a real bad guy, I'm going to actually make my font a little bigger. If I were a real bad guy, I would be using an exploit against the CVE itself. So a CVE would be something like an instance that has not had its operating system patched appropriately. Usually that is due to people forgetting about these compute resources, which happens all the time. And they get out of date, they have known vulnerabilities. And then if you're even not a very competent bad guy, if something has a CVE on it, you can go on the internet and find exploitative code to get you shell on that. I'm not going to do that today because AWS looks for people doing those kinds of things because they're pretty much always people doing harm, and they will potentially shut me out if they notice. So I'm just going to pretend like I've hacked into that EC2 instance using the known vulnerability, and you'll have to trust me that that's actually quite easy to do. But in this case, I'm just going to shell to it. So you can see here, I've gotten to an Amazon Linux AMI. It announces that to me. It's proudly an EC2 instance. Here's the interesting line. 9 packages needed for security out of 63 available. It has not been patched appropriately, right? I would need to be running this command to bring it up to speed. So very often what we see at Fugue, when we show people a diagram like this, and this is a really simple environment, a lot of our customers have tens of thousands of resources, and they'll say, hey, what is that thing? How long has that been there? You know, and they'll go and use the visualization to try to understand what they have in their environments. And the reason for that is it's really easy to lose track. So in this scenario, and this scenario is based on a major hack that happened last year, this compute instance was forgotten, is out of date, and therefore I could shell into it. Okay, so if I'm a bad guy, what I need to do is discover your resources. I don't know what the resources are in your cloud account, right? I've just found through my scanning, I've just found that this compute instance has a vulnerability that's exploitable, and I've gotten in there. I don't know anything about these S3 buckets, right? Because that's all I've seen so far. So I need to start learning about your environment. So I'm going to try the AWS S3 command to list buckets. Well, it looks like Acme Corp here has done a good job in that I just had access denied. I cannot list those buckets. So the command I typed is the AWS command line, AWS, then S3, and then LS. So S3 the service, LS is list. I just hit a bit of a wall. I can't even see those buckets. I can't see the data. When you look at these major breaches, often there are hundreds of S3 buckets and millions of records that are being stolen. And because here, the cloud folks who put this environment together denied me the ability to do lists, that really makes my job harder. So that's a bit of a dead end. But I'm a clever bad guy, so I'm going to change tactics. Let's go ahead and I'm just going to do some copy and pasting here to keep things nice and simple and not make this demo last for too long. Okay, the first thing I'm going to do is I am going to do a listing of what's called the metadata for this instance. So this has made the news a lot. People make a big deal out of the fact that there's a metadata service. It's actually excellent, and if used properly, is one of your best friends in building secure environments. But if I'm a bad guy, yeah, I'm going to take a look around in there. And so what I just did was a curl command, which is just kind of like pointing your web browser at something, but instead of it being graphical, it's at the terminal. I pointed it to this special IP address, 169.254.169.254, which is the hypervisor of the EC2 instance. And I looked for the latest metadata and then threw that back to the screen. And you can see there's quite a few things here I can look into. What I'm really interested in, though, is not everything in there. What I really want to see is this. I want to see what role this EC2 instance is occupying in IAM. I mentioned earlier, the #1 thing our survey respondents were concerned with was IAM misconfiguration. And I mentioned that it acts much like a network. So what way this is working is when we look at this diagram, the way this EC2 instance is able to talk to things is not via, not just via IP addresses, it's via its identity in IAM. And what I just determined by looking at the metadata on this instance is that it is occupying a role, the EC2 instance is acting under the maintenance role. And apparently the maintenance role doesn't allow me to see S3. So I'm going to take a look at something else. Since I know I have been denied access to S3, maybe I can change the identity of the EC2 instance to something that can see S3. So to that end, I'm going to run another command. Again, the AWS command line. This time, instead of pointing at S3 and doing a list, I'm pointing at IAM, Identity and Access Management. And I'm executing the list policies command. And then I'm searching for, grep is a Unix, Linux and Unix utility that is like searching for strings. In this case, I'm looking for stuff that says S3. And this, so I've just gone out and queried the AWS APIs, and I see this S3 read-write role. That looks very attractive to me if I'm trying to get to S3. And we know from the Department of Justice filing, this is in fact, in the breach I'm simulating, exactly what the attacker did. It's a step called IAM role assumption. So we now see that there is a role out there we want, but next we need to assume that role. We need to become that role on this EC2 instance. And I'll point out right now that I have not rooted this box. I have not, I mean, if I do a who am I, I'm going to be EC2 user. I'm not root. I don't care. I don't need access to this operating system in any depth. I don't need access to the TCP IP network. I just need access via IAM to the AWS APIs to get to S3. So I ran a command here. called AWS EC2. So I've now talked to 3 different services. S3 gave me an access denied. IAM, I could get that listing, but now I'm talking to EC2. And in this particular style of hack, a lot of people think that you need IAM permissions to execute this hack, and really all you need are EC2 permissions, which are often granted in a quite liberal fashion. So here, what I've asked EC2 to do is to describe the IAM instance profile associations. All right, that's a mouthful. If I look at this EC2 instance, I'm going to find over here that it is associated with an IAM instance profile, in this case called maintenance role. So you can think of the instance profile as a kind of a connected object. And the association here, right here, the instance profile association is the thing that connects them together. And here I've found its identifier. So now I'm going to do a really long command. Some of these AWS commands are no joke in terms of how verbose they are. And what I'm going to do here, let me just copy this guy. And we'll put it in our terminal here. And by the way, this is all real and real time. I'm not, this is not a simulator, it's a simulation, but it is against real AWS infrastructure. So what I'm doing here, I've said AWS EC2, right? I'm executing a command against the EC2 service. In this case, I want to replace the IAM instance profile association, that connection between the instance and the IAM role that I discovered moments ago. And I'm going to remap this association ID that I just got. And instead of pointing it at maintenance role, I want to point it at the S3 read-write role that looks attractive to my purpose. So let's see if I can do that. That looks like victory. If you're not used to reading code and JSON and things, this is just a block of data that's telling me about, in this case, an IAM instance profile association, again, that connector between the compute instance and the IAM role. And here I now have a new arm. This one says S3 read-write. Before it said maintenance role. So I've changed the identity that EC2 instance is operating under. Let's see if I can get to S3 now. I can. Before, if you recall, this said access denied, right? Up here. When I tried it, it was access denied. I could not see S3. But now, by going and changing the IAM identity, I can see all these S3 buckets. And let's go steal some data. So I'm now going to run a command called sync. This is specifically pointed out in the DOJ filing I've been referring to from the hack from last year. Sync is a really handy utility that will copy everything from something like a bucket, let's call it important, let's get everything from important records, and I want to send it to my hacker bucket, all your base. And what S3 sync is going to do is it's going to compare the contents of those, and it's going to use the S3 API to, in parallel, copy everything. So I just stole all the data out of that S3 bucket, and by the way, none of that data traversed any TCP/IP network boundary. So all of your fancy monitoring tools for networks don't see this. The only indication you have that it happened are some lines in a log that you can find after the fact. So in the case of the breach I'm describing, the good guys, the company that was hacked, only found out their data had all been stolen because the bad guy bragged about it on social media. So how do we deal with this? That is an ugly kind of attack. Just to rewind for a second, we had a number of misconfigurations. I mean, it's actually our survey respondents here were prescient, right? I did leverage IAM in the breach. I did leverage a misconfigured security group. And I did leverage an object storage access policy that was a bit over liberal. Even though I started out with a pretty good configuration, I couldn't get to the object storage at the beginning, but by leveraging security groups and IAM, I managed to get there and steal all the data. So, first misconfiguration is a firewall misconfiguration, right? It's too open. When I scan for that resource, for that misconfiguration, that CVE in this case, I could get to it and I could shell to it. And that is an error. And we know that was an error in that real world breach too. Number two, accessing the EC2 instance, because it had a CVE and was unpatched, it was what we call orphaned infrastructure. It was forgotten about. Anything you don't know about in your cloud is attack surface for bad guys, and they're gonna find it if they have any discoverability into that. So that's the second mistake. The third one is an overly liberal IAM policy on EC2, actually, EC2 permissions, in order to allow me to change the IAM role to get to S3. And then the fourth error, the fourth misconfiguration, was the ability to make list commands against S3. Now, people don't think about list as an attack. List is a devastating thing to open yourself up to if you grant it to bad guys, because they're doing discovery. And if you imagine, you know, again, in that particular breach, it was 700 S3 buckets. There's no way that I could guess the names of 700 different S3 buckets. That really raises the bar. But because I can do list, I can just enumerate them. And by the way, the sync command that stole all the data relies on using the list command. So if list were turned off, this would not have worked. It would have been much, much harder for the bad guy to get to the actual data. So that's what I had to show you today. Actually, I'll show you one other thing, which is Fugue will tell you about all of these and many other misconfigurations. You can go to fugue.co/go and get a free trial, and our developer version is free forever. And you can point this at your AWS account, and it will tell you things like, for example, this security group is too liberal. It will tell you about the security group misconfigurations, and it will also tell you things like when somebody changes IAM roles, which is really dangerous. If you will pick up on that drift. So this is what we do. I hope you learned something new today, and this was helpful. And please,
Josh,
yes.
Quick question. You know, especially with, as you said, cloud architectures are very fluid. What you provide, and you've got such a wealth of experience across a range of these public cloud instances, you'll, meaning Fugue, continually monitor an organization's cloud architecture, cloud configurations, and very quickly and immediately identify these anomalies, these misconfigurations, so organizations can correct them, because it's not as if they can physically go down to their wiring room, their mini data center in the basement of their corporate complex to fix these things. Is that reasonably correct?
Yeah, that's exactly right. We do that. And in this environment that I'm showing here, we're set to look at it every 10 minutes. And we're set to notify if anything changes in a dangerous way. You can also tell Fugue, and I couldn't turn this feature on for the demo today because it would have blocked me from doing the hack, but you can also tell Fugue that if anything changes, automatically put it back to the correct state. So if a bad guy gets in like I did and starts messing around, Fugue can both, it will notify you, it will notice, it will put it on this diagram, it will tell you what's wrong. But if you ask Fugue to, by turning on this enforcement feature, it will actually revert what the bad guys are doing while they're doing it. So I turned that off because I wanted to actually do the hack. But yeah, that's what we do. And again, there's a completely free forever version called Fugue Developer. It'll operate on up to I think over 1,000 cloud resources for free. If you have many thousands, then we do ask to get paid, but the developer version is free forever and you can try it now.
Let me ask you a couple of other questions. First of all, when organizations are looking at other cloud providers, such as Microsoft Azure, do you have some capabilities for understanding and monitoring other public cloud platforms?
Yes, we do. So right now we support both AWS and Azure. You can see right here is an Azure environment, and it's just right in the same interface with the AWS environments. It all works the same way. You can point Fugue at either end or both. We're going to have Google support imminently. That's right now in testing. So Fugue gives you this kind of look into your security posture across all the major public clouds. We support, you can see here, a lot of different compliance standards across those clouds. And we also add in on our own. I mentioned earlier that the big standards like CIS and NIST and so on aren't keeping up with the bad guys. Well, we now make our own best practices, which will catch. So every time there's a major exploit in the news, I and my team try to figure out exactly how it happened, and then we'll build new policies that will tell you if you're vulnerable to the attacks that are really being used out there in the wild.
Hey, Josh, one other question, and or you can maybe confirm this. There's a lot of talk around the shared security responsibility model of the cloud. You know, here's what AWS does primarily on the infrastructure side, or Azure. You know, they're obviously doing a tremendous amount, but they being the public cloud providers, deal with security in this element. And then you've got the end user, the organizations whose main security focus is the overall strategy and keeping very close tabs on securing the data that they need to continually own and secure. But we find that there's always a need for a trusted third-party security vendor like a Fugue to help bring these pieces together and look for things that by, you know, really it's no implicit bad actions, but when you look at misconfiguration, so much going on, someone might have mistakenly forgotten about this instance or forgot to turn off this virtual machine, whatever the case may be. You know, that's where you can't necessarily rely upon your internal IT group fully. You can't necessarily rely upon completely the AWS Azure security teams. You often and frequently need experts like Fugue just to fill that last remaining gap to ensure that everything in your applications, in your data, in your compliance activities, in your regulatory submissions are clean and secure. Is that about right? That, you know, the shared security responsibility really is three components: the organization, the cloud provider, and third-party providers like Fugue.
Yeah, well, I certainly think so, and that's why, excuse me, prior to founding Fugue, I was actually a principal solutions architect at AWS, and I and my colleagues at AWS saw this as a problem that really did need specialized third-party, you know, attention. And my career background is a kind of mix between national security and high tech and startups. That's been my focus for decades now. So that's why, you know, that's why Fugue exists. And I think that when people see cloud breaches, they very often think, well, we're smarter than those guys who got hacked. I am here to tell you that even the smartest folks, I mean, at Fugue, we built this product to be highly secure, but of course we run Fugue against Fugue itself to make sure we're right, because it's incredibly hard when you're dealing with the amounts of infrastructure that are appearing and disappearing all the time to really wrap your head around that security posture. Of course, we also do things like give you reporting and data for proving compliance for audits and all kinds of other features. You know, this wasn't really a product demo. I was just showing you a little corner of the product. Okay. But yeah, I think you're exactly right.
I think one of the things as we bring this to a close is people look at Fugue, and you know, at least my understanding, having gone around the country talking to people, I and this trying to encapsulate it, I look at Fugue as basically penetration testing, ethical hacking, which has traditionally been done on-prem on a very controlled environment. They have expertise but are doing that in a cloud environment, and that's why we're so excited to have experts like Josh speak at our shows around the country, and hopefully you'll get a chance to hear Josh in person, or at the very least, learn about this. You can always go to angelbeat.com. You can contact us there if you have any questions, as well as going to fugue.co and getting more information. Anything else you want to add, Josh?
No, I think that does it. And thanks for the time and the opportunity, everyone that put your attention to this. This was a lot of fun.
This is great stuff. And remember, when people come to AngelBeat, they learn from experts, they stay out of the headlines. I'm a little biased here, but I can tell you for most of the organizations that you hear about in the headlines, they didn't make an AngelBeat event in the last couple of years. So I'll look forward to having you at a future live event, and please take advantage of our online training. Thank you very much. And I'll end the webinar now.
All right, cool.